Hello, I'm John from Dad's Shed. This is the second video, and I decided after the first one I'd invest in some small cameras to set up in the workshop environment to help improve my offering. That was a big mistake because the cameras I got I cannot find without the access to a bleep machine an adequate description of their quality. It was truly appalling, but I only discovered this when I started putting the videos together in the edit. So it's not as nice as I would have hoped, but it still does show all the processes, all the major processes at least, in the production of the improved Toolpost mount. It goes through lathe work, shaper and drill. I think it covers all the things you would like to see. I hope so. And I hope you enjoy it despite some fairly dodgy video. It does actually show everything. The next one will be much better because I now know what I'm dealing with and I've taken steps to improve it. So I do hope you enjoy this. I'll now leave you to my other self to take you through what we've done in Dad's Shed. Welcome back to Dad's Shed, and this is the second of the videos I'm producing. In the first one I mentioned an ongoing project I've got to improve the tool post on my primary lathe, this Colchester Bantam, and today I'm going to put together the video that goes through the process of making the changes to that. As a quick recap, on the Colchester we have a top slide or compound slide that has a T-slot in it, and in that T-slot lived this, which is the T-bolt, and as you can see it's not in particularly good condition and it's beautifully curved. I don't know how old that is. I haven't changed it since I got the lathe some 12-14 years ago, so came with that tool post, but over the years, tightening and untightening the tool post itself, obviously this has been pulled out of shape, and the only thing that holds it in the T slot is that, and it's a fairly rattling fit. There is a rebate cut into the top of the compound slide above the T slot, which enables this bush to go in, and that fits over the top there and locates it so it doesn't move across the top slide. So the project is to make a new T-nut, a new stud, but I'm going to improve it as well by incorporating into the top a thrust washer, a housing and cover for the thrust washer, and a new top nut which will have a handle on it, so I don't need to keep going back to the rather large spanner that a 5/8 Whitworth nut needs. So this will include some work on both of the lathes, and normally I'd set up and do the T-nut in the milling machine, but as I mentioned before, the milling machine is set up to do some bevel gear cutting, and it took me quite a while to set that up. I'm part way through it and I really don't want to split that down. So I'm going to use the shaper for that to cut down the two sides to create the T on some steel stock. Most of the material has come from my favourite source, the scrap skip, and it's mainly high tensile bolts. So the cost of doing this is very little. The only two things I have bought in for this and not either had in stock or came free is the ball on the end of the arm for the top nut and the thrust bearing itself, and I think the total cost of those two items comes to about £7. So quite good from my point of view and point of view of my wallet. But what I'll do now, through the magic of video, is we will go forward in time a week or so to after all the parts have been completed, and my slightly older self will take you through exactly what I'm making, and then we'll come back to today and we'll get on with actually manufacturing the parts that we need. I hope you enjoy it. By the magic of video, of course, we have a time machine. So what I've got here laid out on one of my benches is the components for the improved Toolpost. So we have here the T-nut with the rebate in it. Over the top here is the bush that fits in there. Next to it is the stud, very short 5/8 BSF at this end, 5/8 Whitworth at this end. Then the base plate that fits on the top of the compound slide above the stud, and the other side of that is also rebated to take this. Then we have this little housing that takes the thrust bearing. It's 5/8 internal diameter thrust bearing. So those three pieces slot in there like so. And that then sits on the top of the quick change tool post. Then we have the top nut, 5/8 Whitworth in there, 1/2 inch Whitworth in that end. It could be 12mm if that's what you work with. And then the locking arm, which screws into here, 1/2 inch Whitworth, 10mm. And the reason it's 10mm is that the ball is 10mm, and they're an awful lot easier to get and an awful lot cheaper to get in metric sizes than they are in imperial. So they're the components, which I'm now showing you before I've even made them. Isn't it amazing, this video stuff? Absolute H.G. Wells time traveller. And we'll just look very, very slightly. If I look slightly that way, look slightly that way, we've got the new spindle and the new milling head vertical section. Yes, we'll come back to that at some point in the future. But at the moment, that's the bits. Now I'll show you how they're going to get made. So we're here at the shaper, and the first thing to do, as with many machine tools before using them, is to give them a little bit of lubrication. Now the shaper doesn't get used that often, so I'm going to give it a good lube and then we'll get it running. I've just taken a quick touch cut on there to get it lined up, and all I'm going to do is just literally run it across the surface in a moment or two. But first off, let's get some lube on it. Okay, so that's the top of that face down. It's sitting on parallels, tapped down in the vise, so that should be nice and square. So what I'm going to do now is reset this, turn the whole thing through 90 degrees so that I can go along the work, and then I need to raise it up on higher parallels so that the whole thing will enable me to cut down 1/4 of an inch to give a 1/4 inch thick base and a 1/2 inch thick centre. So I'll start that setup now. Okay, let's see where we are with this. I've set this up now. Just put a dial gauge on there, tapped it in, and that is not moving at all. That's really rather nice. Well, that's a nice fit. That's a push fit. Excellent. So having marked up and centre punched the workpiece, now stuck it in this 4-jaw on the Myford, because I've got a tool post on this one. I'm just using a running centre sitting in the centre punch to line it up while I'm getting the jaws sorted out, and the next move will then be to get that centred using a centre finder to make sure it's spot on, and then I can drill through, tap 5/8 BSF, and then counterbore the top to take the alignment bush. So this is a hybrid job. What I've done is I've screw cut at 14 TPI using this out to as far as I can realistically get, which is very, very close actually to 5/8 BSF. And then I'm going to use the tap just to run through and clean it up. I know it's going in square because it's going into the thread that I've already tapped in there. So that's in nice and solid. It's just starting to bite. So I'm going to go the rest of the way through with that, but I'll take it out of the lathe and I'll put it on the bench to do that by hand. Well, I've tapped out the hole in the T-nut, but I forgot one thing. I hadn't actually completed what I was doing on it, and I need to bore out the counter bore at the top a bit greater in diameter to fit the sleeve that goes into the compound slide. So I've had it put it back in here in the 4-jaw and clock it, so that is quite nice. That's running to less than 0.01 of a mil, so I'm quite happy with that. So what I'll do now is measure the size of the piece I've got to make to go in there, and then bore it out to suit, and then that will be that bit done. Although I'm thinking I may actually, a little bit later, when I've got the sub plate that goes on, I think I may just dowel pin into it to keep the sub plate in place, stop it wobbling around. Into the T-nut I'm making will actually be 5/8 BSF. And that is the back end of it, so I'm just going to tuck off there. Now the most important thing is to know what sort of depth I want. I'm going to the old favourite, Zeus. I can just check on that, and it will tell me that for British Standard Whitworth threads, 5/8 Whitworth, the core diameter is 0.5086 and the depth of thread is 0.0582. So 0.0582. Now put 0.0582, 1.47 millimeters. So let's say 1.5 millimeters, and that will give me more or less what I want. So I've zeroed the dial on this. A little bit of mental gymnastics, because this shows the feed in, so 10 on here is half a mil fed in, but 1 millimeter off the dial. And and I want to feed in 1.5, but if I do that, that only takes 1.5 off the diameter and not give me 1.5 feed in. So I need to feed it into 30, which is effectively 3 millimeters. That will be 3 millimeters off the diameter. That's 1.5 mil feed in. Yeah, sometimes doing these things just requires a little bit of mental gymnastics to get your head around what you're doing. So that's prepped ready now for some screw cutting. So I now need to go away and set up my screw cutting tools with the right tip to cut an 11 TPI thread. I'll see you in a moment. Okay, I've just done some marking on this. What I'm going to do now is bring this in. Now, if I find my nice little Moore and Wright thread gauge and lead it against there, that's 11 TPI, exactly where I want it to be. Right, I've zeroed my cross slide. I'm doing a straight in. I'm not using the angled approach, which a lot of people do. With this compound slide, I'm never happy with exactly what feed I'm getting. So I'll just use the cross slide and feed straight in. I've got to pick it up on the same place on the dial indicator because I'm doing an odd numbered pitch. Means it's a lot slower than it would otherwise be. I'll give it a touch of cutting oil. Just missed it, so I'm going to have to wait for it to come all the way around again. It's definitely getting close. So what I'll do, let's blow that off a moment. not quite. It's close. There's probably only another couple of hours to go on that, which is about right according to the speed dial. So we'll do another pass. I've just taken a couple of other more passes. Much more depth of cut. Just about to go on. Now, am I missing something here? Ah, I've got a broken tip. That's just what I didn't want. So, let's blow that out. Now, the one advantage of tipped tooling, of course, is that in theory, when I just turn this round, it will be in exactly the same place as the original one. And it will tighten down into exactly the same spot. Not much, not at all. Very, very close. Just do a couple of spring passes here. That should be there we go. That's nice. No rock. Nice tight fit.